In this video, we're going to draw another graph of a Bode plot. Once again, we're going to start by rewriting it into the form that is convenient for that. Now, in this case, since it's j omega plus 2, what I'm going to do is I'm going to factor the 2 out so that it becomes 1 plus j omega over 2. That's the format we prefer. Same thing on the bottom. Since it's j omega plus 10, I'm going to factor out 10 there and make it 1 plus j omega over 10. And then I'll factor out 100, making that 1 plus j omega over 100. Then I'll go ahead and combine together all the individual constants in the front. I have 10 to the fourth is 1,000, divided by 10, divided by 100. Sorry, 10,000 over those is going to give me 10 times 2 is 20 is going to be my K number. And then I'm going to have break frequencies at 2, another break frequency at 10, and the last break frequency at 100. Now, as we saw before, for the part which is K equals 20, we're going to have 20 log of 20, and we can put that in our calculator to see what number it's going to be in terms of a decimal. It's about 26.02. So the constant's going to give us a flat line with a height of 26.02. Then if we look at the 1 plus j omega over 2 factor, that has a break frequency of 2. Starts out flat. Since it's in the numerator, it's going to then go up with a slope of 20 decibels per decade. Next up is the 1 plus j omega over 10 factor. That is in the denominator. So once we reach our break frequency of 10, it's going to go down with a slope of negative 20 decibels per decade. And the last factor, 1 plus j omega over 100, has a break frequency of 100. Starts out flat and goes down at negative 20 decibels per decade. Now, when we want to put together and draw the overall Bode plot, we need to figure out our break frequencies. We have 2, 10, and 100. So I think the easiest thing to do would be mark 1, mark 10, mark 100 for our decades, and just realize that 2 is going to be a little bit in here. Now we know that before all the break frequencies, the only thing we have is the flat line. So the graph will start at 26.02. When we reach our first break frequency at 2, that is when it starts going upwards here. So it's going to go upwards with a slope of 20. Then we're going to reach at the 10 point here. At 10, we're going to add negative 20 to our slope. Well, since our slope was previously positive 20, it's now going to be a slope of 0. And then when we reach the last break frequency of 100, then we can go ahead and say it's going to add an additional negative 20 to our slope, and it's going to look something like this, with our slope of negative 20 decibels per decade. Now we could figure out how high this plateau is. I'm not going to really have us worry too much about that, though. As long as we get the general shape right, all the slopes right, that's good enough for what we have. The break frequencies are easy to show on the graph and so on. That's really what I'm looking for. In reality, in modern day times, you would just use a computer to draw the graph for you anyways.